Okay, let's look at some problems on sequential series. First problem, if ak is equal to 1 by k into k plus 1 for k equal to 1, 2, 3 so on up to n, then sigma ak k ranging from 1 to n the whole square is equal to n by n plus 1, n square by n plus 1 whole square, n power 4 by n plus 1 power 4, n power 6 by n plus 1 power 6. Now let's look at this problem. Whenever sum up to n terms of some series is required, we first try to bring the nth general term as a difference of two consecutive terms. That method of splitting the general term as a difference of two consecutive terms of some other series is called the telescoping method. So let's look at the telescoping method here. ak is equal to 1 by k into k plus 1. We know this. So can I write this as a difference of two consecutive terms? Very clearly, it is 1 by k minus of 1 by k plus 1. So here you observe that k plus 1 minus k by k into k plus 1, that makes it 1 by k into k plus 1. Now sigma ak, k ranging from 1 to n, will mean 1 by 1 minus 1 by 2, that is a1, plus 1 by 2 minus 1 by 3. K is 1 here, k is 2 here, so on so forth. You go on like this, write k equal to n. So what do you get? 1 by n minus 1 by n plus 1. You see that all the middle terms will get cancelled and you will be left with the first part of the first term and the second part of the last term. That makes it 1 minus 1 by n plus 1. So all the middle terms get cancelled. And what do you get this to be? N by n plus 1. Okay, so now what you want is sigma ak, k ranging from 1 to n, the whole square of it. So what is that? N by n plus 1 the whole square. So clearly it is n square by n plus 1 the whole square. So the technique that we have used was, we have written the general term, that is the kth term of that series, which we are trying to compute as a difference of two consecutive terms of some other known series. Don't you see that this is 1 by k? If this is the kth term, this is the k plus 1th term, they are consecutive terms. So that's the key. And this method of doing problems, of finding out sum of the series, is called the telescoping method, and we have adopted it. Therefore clearly the answer is 2 there. Now moving to the next question, question number 2. Here sigma k ranging from 1 to infinity 1 by k factorial into summation, again n ranging from 1 to k 2 power n minus 1 is equal to, first option e, second option e square plus e, third option e square, and fourth option being e square minus e. Now let's look at this problem this way. There are two summations involved. Let us look at the first summation first, the inner summation. Let's resolve the inner summation, n ranging from 1 to k. Now if you write it in the expanded manner, what do you have here? N is 1, so I'll get 2 power 0 plus 2 power 1 plus so on and so forth, 2 power k minus 1. Now we find that this is a series which is in the geometric progression, and this is sum up to how many terms of this geometric progression? K terms, 0 to k minus 1, there are k terms there. So, and now what is the formula for sum up to n terms of a GP? A into 1 minus r power n by 1 minus r power n minus 1 by r minus 1. So we will take this, a is the first term here, 1 into, how many terms have, what is the common ratio? Common ratio is 2. So 2 raised to the power, number of terms, k. So 2 power k minus 1 by 2 minus 1. So that makes it 2 power k minus 1 there. So this summation, the inner summation, is coming out to be 2 power k minus 1. What we wanted was sigma 1 by k factorial into k ranging from 1 to infinity of this summation 2 power n minus 1 n ranging from 1 to k. Now what did this come out to be? This summation came out to be 2 power k minus 1. So let's write that. That's coming out to be 1 by k factorial into 2 power of k minus 1, k ranging from 1 to infinity. Now observe that this is the form sigma 2 power k. I will split this summation into two summations. Sigma 2 power k by k factorial, k ranging from 1 to infinity, minus sigma 1 by k factorial, k ranging from 1 to infinity. Okay. Now observe, we can even rewrite this as, we will add a 1 in both the places. We add a 1 in both the places. That is, it's as good as adding and subtracting. What do you observe? This 1 we can write it in the form of 2 power 0 by 0 factorial. 0 factorial is 1. So we can write that in that fashion. So then this summation can be rewritten as sigma 2 power k by k factorial, k ranging from 0 to infinity. And what about this? This comes out to be sigma 1 power k, or simply 1 by k factorial, k ranging from 0 to infinity again. We know one formula. What is that formula? E power x has an expansion like this. Sigma x power k by k factorial, k ranging from 0 to infinity is e power x. We can use this for, now just observe that instead of x we have 2 here. So this becomes e square. This part becomes e square. So this is e square. And what about this? Sigma, I can take x to be 1 here. So 1 power k is 1 there. That makes it e there. So e square minus e. So what we have made use of was this. Okay. So we have, in fact, we have dealt with this problem this way. First we have found out what is this inner summation value, and then we went for the outer summation, and we used the fact that e power x is equal to sigma x power k by k factorial, k ranging from 0 to infinity. So this has to be borne in mind. This is the formula that we have used here, and we also made use of the geometric progression sum up to n k terms of the GP formula there. So the answer is 4 there. Clearly the answer is 4. Now let's move on to the next question. Coefficient of x power 10 in the expansion of 2 plus 3x into e power minus x is first option minus 26 by 10 factorial, second option minus 28 by 10 factorial, third option minus 30 by 10 factorial, fourth option minus 32 by 10 factorial. Now let's see how we go about this problem. Where is the expansion at all? So 2 plus 3x is a linear expression in x. What about e power minus x? E power minus x has an expansion, infinite series expansion, but we are interested only in the coefficient of x power 10 there. So first what we'll do is, we will write the expansion of e power minus x. What is the expansion of e power minus x? 1 minus x plus x square by 2 factorial, minus x cube by 3 factorial, so on and so forth. Alternating sign pattern there. Now 2 plus 3x into e power minus x will mean 2 plus 3x into this 1 minus x plus x square by 2 factorial, so on and so forth. What will be x power 9 term? It will come with a negative sign. Odd power terms are coming with a negative sign, even power terms are coming with positive sign there. So I will have here a minus of x power 9 by 9 factorial plus x power 10 by 10 factorial, and this alternating sign pattern will go on. Now we are interested in the coefficient of x power 10 only. So now when you multiply, so here we have an x power 0 term which you have to multiply with an x power 10 term to get the x power 10 term. What is the x power 0 term? It comes with, that is the constant term, that comes with the coefficient 2. What about the x power 10? It doesn't come as it is, it comes with some coefficient. So 1 by 10 factorial. So when you multiply, what is it you get? 2 by 10 factorial. 2 by 10 factorial there. Now coming to Now how else can we pick up the x power 10 term? That is, you can take an x power 1 term from this first factor and x power 9 term from the next factor. So what is that? X power 1 term comes with 3 as the coefficient, so 3x into, what about here, x power 9 term, it comes with the coefficient minus 1 by 9 factorial. So when I am picking up the coefficient of x power 10 now, let's look at the coefficient of x power 10, that makes it 3 into minus 1 by 9 factorial, so minus 3 by 9 factorial. Okay, minus 3 by 9 factorial. So these are, when I am clubbing the x power 10 terms, this as well as this will come out as the coefficient. So when the final coefficient will be sum of these two. So sum of these two, that is 2 by 10 factorial, required coefficient will be 2 by 10 factorial minus 3 by 9 factorial. You can take out 1 by 10 factorial common here. When you take out 1 by 10 factorial common here, so you get 2 minus, what do you get here? 3 into 10. You've got to compensate, because 9 factorial, if you have to make it 10 factorial, you'll have to multiply and divide by 10. So multiply and divide by 10 here. Okay, now it is made 10 factorial. So 1 by 10 factorial has been taken in common. So what do we have here? 2 minus 30, that makes it minus 28. So what is the right option? The right option is minus 28 by 10 factorial, which is nothing but the answer is 2 there. Okay, so that's the answer. So here we are making use of the expansion of e power minus x, and then we are picking up the required terms in the product. Now let's look at the next problem, that is sum of the series 3 plus 5 plus 9 plus 17 plus 33 so on up to n terms is 2 power of n plus 1 minus n minus 2, 2 power n of n plus 1 plus n minus 2, 2 power n plus n minus 2, 2 power n plus 1 minus n plus 2. Now one way of tackling such problems is, we can give some value to n. That is, suppose I give n is 1, then what is the sum up to 1 terms? It has to be 3. S1 is 3. Sum up to 2 terms would have been 8. 3 plus 5, 8. So which of these formulae will be satisfied for n equal to 1 and n equal to 3? You can see, plug in the values and verify. This is one way of tackling this problem. Other ways is that let's go for the general pattern. That is, let's see some pattern in the sequence that is involved in it. Is there any sequence involved in it? 3, 5, 9, 17, 33, these are the terms. Okay, this is the underlying sequence here. What is the difference here? We'll look at the differences between the consecutive. So we have 2, then 4, then 8 here, then 16 here. So very clear. Now if I want the nth term of this original series, what is it I must be doing? Look at this. To get this 17, this value, let's say T4, what is it you had to do? T4 here. With the first 3, you add 3 consecutive terms of this. That is, you are bridging up the gap. 3 plus 2 plus 4 plus 8. That makes it 17 there. Okay. 12 plus 2, 14 plus 3, 17. That's bridged here. So if you want 33, start from here, bridge up the gaps, and that makes it 33 here. So 3 plus 4, 2 plus 4 plus 8 plus 16 will give me 33. So tell me now, what will be this Tn? How do you get this Tn? 3 plus 2 plus 4 plus 6 so on up to here you have n minus 1 terms of this. Let's call this as a new series un minus 1. So up to this, if you add up 3 with this differences, you will get Tn. So what is Tn here? Nth term of this progression, that is 3 plus 2 plus 4 plus 6 plus so on up to n minus 1 terms here. N minus 1 terms here. Now it's clear that we'll write this generalized term. How many terms have been added up here? N minus 1 terms. They are in AP. So in fact you can take out a 2 common, and we have 1 plus 2 plus 3 plus so on up to, okay, you have n minus 1 terms. So sum up to n minus 1 consecutive natural numbers, that makes it 3 plus 2 into n into n minus 1 by 2. So n into n minus 1 into n by 2, that makes it 2 cancels, and you have n square minus n plus 3. That's a general term. Just check out. If n is 1, it's matching. N is 1, we have t1 to be 3. What about 2? 5. 2 square plus 2 square minus 2, that makes it 2 there. 2 plus 3, 5. N equal to 3. 3 square minus 3. 9 minus 3, 6. 6 plus 3, 9 is matching. So this is the nth term of the given series. Now I want sum up to n terms of this series. So what is tk here? I'll write this as k square minus k plus 3. Now what we want is sigma tk, k ranging from 1 to n. This is what we want. So that makes it sigma k square minus k plus 3. Now we can split this up as sigma k square, that is sum up to first n squares of first n natural numbers, minus sigma k, k ranging from 1 to n, and plus 3 summation, 3 added up n times, k ranging from 1 to n. So that makes it, okay. Now what is sigma k square, k ranging from 1 to n? We know that is sum up to first squares of first n natural numbers, that is equal to n into n plus 1 into 2n plus 1 by 6. And what about sigma k, k ranging from 1 to n? That is equal to n into n plus 1 by 2. When you say sigma 3, k ranging from 1 to n, so 3, what is that? That means 3 is getting added up n times here. So it's a constant thing that is getting added up n times. So we have 3n here. Now add up all this, this minus this plus 3n. After simplification, that turns out to be in the form of 2 power n plus 1 plus n minus 2. So that makes it 2 power n plus 1 plus n minus 2 there. So that's how we can arrive at it. Now if A, B, C are in harmonic progression, then A by B plus C, B by C plus A, C by A plus B are in arithmetic progression, harmonic progression, geometric progression, none of these. So let us look at how to go about this. A, B, C are in harmonic progression. So what is that immediately that we can conclude? 1 by A, 1 by B, 1 by C are in AP. 1 by A, 1 by B, 1 by C are in AP. Now when you have a sequence which is in AP, if you multiply throughout by every term of that sequence by some constant, it still will be in AP. So let's do that. What we do is we'll multiply throughout by A plus B plus C. Multiply throughout by A plus B plus C. So that gives me, this is also in AP. In AP. Now observe that we can split this into two fractions. A by A, that makes it 1. 1 plus B plus C by A, comma. Then remove this here, you will get B by B as 1, and then the rest of the part is A plus C by B. And then you have 1 plus A plus B by C. I can rewrite it. These three terms are in AP. When you subtract or add a constant which is in a sequence, constant from every term of a sequence which is in AP, it's a resulting sequence will also be in AP. So here I'll subtract throughout, every term has a 1 added up, so we'll subtract 1 from each of them. So what do we get? B plus C by A, comma, A plus C by B, comma, A plus B by C, they are in arithmetic progression. So now what's immediate? I can take the reciprocals. What is it you observe? The reciprocals. A by B plus C, comma B by C plus A, comma C by A plus B are clearly in HP. So clearly the answer is 2. So manipulation here, that what we have used was, so when you multiply each term of a sequence which is in AP by a constant, the resulting sequence is in AP. You add or subtract each term of a sequence which is in AP with a constant, the resulting sequence is again in AP. So this is what we have made use of in this problem. Okay, answer is 2 then. Okay, the number of terms common between the two series 2 plus 5 plus 8 so on up to 50 terms and the series 3 plus 5 plus 7 plus 9 so on up to 60 terms is 24, 26, 25, none of these. Now let us look at, first of all, what is the question that is asked here. The resulting underlying sequences. We have first sequence that we have is 2, 5, 8. The next term, the common difference is 3 here, 3 here. Next is 11. What do you guess as the next term? It should have been 14, so on and so forth. What would have been the 50th term? So T50 would have been here 2 plus 50 minus 1, that is 49 into 3. That makes it 149 there. 120 plus 27, 147 plus 2, 149 is the last term, that is the 50th term here. Now let us look at the second series, the second progression. We have 3, 5, 7, 9, 11, so on and so forth. Now what is the common difference? This is also in AP. The common difference being 2 here. 2 here. But now you are looking up to 60th term. 60th term. What is that? What is the 60th term? 3 plus 59 into 2. Okay, A plus n minus 1 into D. That is the nth term of an AP. So 3 plus 59 into 2. That makes it 118 plus 3, 121. Okay, so 121 is the last term of the second series and 149 is the last term of 50th term of the first series. Now we have to look for the common number of common terms of these two series. Let's look at the first common term that you have here, 5. And then these are moving in steps of 3, these are moving in steps of 2. So what is the least common multiple of this 3 and 2? 6. And now what you do is you generate a new series, 5, next 11, okay, that's common difference is 6, then 17, okay, 17, that's also in this series. So go on like this. Now these are definitely going to be the common terms here. You see that 5, then 11, then we have 17, 17 will come here, and we'll have 11, 13, 15, 17 will come here also. So the sequence, common terms, sequence of common terms is this. Of common terms is this. Is this. Okay. Now he has asked what should be the number of terms common to this. So I must see that the last term should not exceed 121, and it should obviously it should not, when it is not exceeding 121, it will not exceed 149. So what I have to look at is 5 plus what is the largest term, for what is the largest value of n for which 5 plus n minus 1 into 6 will be less than or equal to 121. Largest value of n, so which will be, okay, satisfying this, that is n minus 1 into 6 should be less than or equal to 121 minus 5, that makes it 116 there. So n minus 1 should be less than or equal to what here? 116 by 6. That makes it 116 by 6, that is approximately 19 point something. So n has to be less than or equal to 20. Okay, so 20 should be the number of common terms we have here. The largest value of n is 20 there. So 20 should be the number of common terms, and none of the options are giving us that. So answer is 4. If a1, a2, an, a3 so on up to an are in arithmetic progression with Sn as the sum of the first n terms of it and S0 is 0, then sigma nck k ranging from 0 to n of nck into sk is equal to 2 power n minus 2 into na1 plus Sn. Second option 2 power n into a1 plus Sn. Third option 2 into na1 plus Sn. Fourth option 2 power of n minus 1 into a1 plus Sn there. Now what is it we require? He has given that a1, a2, an are in AP. So here let's assume that a2 minus a1 is D, a3 minus a2 is also D, so on, an minus 1 is D. The common difference, D is the common difference of the AP. Now what is Sk here? Sum up to first k terms of this. That makes it a1 plus a2 plus so on ak. Alright, so that makes it, what is the sum up to k terms of an AP? We have here k by 2 into 2a1, that is 2 times the first term, plus k minus 1 into the common difference D. That is it. Now we are interested in nck into sk, sigma k ranging from 0 to n. So what is nck into sk? That makes it k into, let's open it up, let's take this 2 inside. We have k into nck into a plus k into k minus 1 by 2 into d into nck into d there. Now what is this nck into sk? We want nck into sk k ranging from 0 to n. So let's apply the summation both sides. So sigma k ranging from 0 to n, sigma k ranging from 0 to n here. Okay, observe that this part a is common in every term. A is common in every term, so we'll pull it out of this summation. So we get a into sigma k ranging from k into nck. Although we are writing k ranging from 0 to n here, we can easily observe that when k is 0, I will have the term to be 0. So let's not write that. So we'll write from k ranging from 1 to n. And then here, the first 2 terms will be vanishing here. D can be brought out of the summation because D has nothing to do with the k there. So D can be brought out. One more thing that we have to observe is when I put k equal to 0, some term will be 0. K equal to 1 also gives me the term to be 0. So what we have here is sigma k ranging from 2 to n of k into k minus 1 into nck here. So now let's have a look at this. Do we know these summations? Sigma k into nck, k ranging from 1 to n, and do we know this? These are some standard summations here. Sigma k into nck, k ranging from 1 to n. What is that equal to? That is n into 2 power of n minus 1. How do you get this? K into NCK is coming up, will be, when you supply K to this NCK, N pops out, this both superfix and suffix are decremented by 1, and N minus 1 CK minus 1. So now when you take the summation, using, this is the sum of binomial coefficients of the expansion. So when I take sigma K ranging from 1 to N, so I am putting a question mark, why is this? I am trying to explain here, then that comes out to be K ranging from 1 to N here. So this will be N minus 1 C naught, N minus 1 C1, N minus 1 C2, so on up to N minus 1 Cn minus 1. That is nothing but the sum of the binomial coefficients in the expansion of 1 plus x power n minus 1, and that will be 2 power n minus 1. So that is n into 2 power n minus 1 there. Similarly, when you go for sigma k into k minus 1 into nck, k ranging from 2 to n, that turns out to be n into n minus 1 into 2 power of n minus 2. Okay, so we can use these two values here, and we have a1, this is a1 here actually, so a1 into, what is that, n into 2 power n minus 1 plus d into, what do we have this to be, n into n minus 1 into, there's a 2, 1 by 2 also, this n into n minus 1 by 2 into 2 power of n minus 2. Okay. Now after, we can take out 2 power n minus 2 common from both of them, and when you take out 2 power n minus 2 common, we have here n a1, n into 2 into a1, n into 2 a1 plus d into n minus 1 into n by 2 into here. Okay, that 2 power n minus 2 has been brought out, so that leaves me a 2 here, 2 into a1 into n into dn into n minus 1 into 2. After a simple manipulation, we can find that this is 2 power minus 2 into n a1 plus Sn. What is Sn? Sum up to first n terms of this series. A simple manipulation will give me this thing. So therefore the answer is 1 there, answer is 1 there. Let's look at this problem. The sum of the series 1 square plus 1 into 1 factorial, 2 square plus 1 into 2 factorial, so on up to n square plus 1 into n factorial is n plus 1 into n plus 2 factorial, n into n plus 1 factorial, n plus 1 into n plus 1 factorial, and none of these. Now as you can actually work out on, you can just take k value n as some 1 or 2 and then see which formula will satisfy it, or going by the general procedure, let's see what is the general term of this. The general term is of the form k square plus 1 into k factorial. The general term is of the form k square plus 1 into k factorial, and you have the summation from k ranging from 1 to n there. Now the method of finding out sum up to n terms of any series is try to write the general term as a difference of two consecutive terms of some other known easily manipulatable series. So what is that? Okay, so what I do is k square plus, we'll add and subtract a k here, and then we'll take out this one way I'm going to write like this. Now the entire thing I'm going to write k factorial, sigma k ranging from 1 to n. Now what is this equal to? This I can write as k into k plus 1. I take this k factorial inside, so k plus 1 into k factorial, and here I have k minus 1 into k factorial, sigma k ranging from 1 to n. Now observe that this k plus 1 into k factorial can be replaced by k plus 1 factorial. So this is k plus 1 factorial. So that makes it sigma k into k plus 1 factorial minus k minus 1 into k factorial. Okay, k ranging from 1 to n. Now, if you observe carefully, if this is the kth term of some series, now replacing k by k minus 1, we are getting this. So let me call this as some uk. If this is uk, that is the kth term of some series, this will be the previous term to that, that is k minus 1. So it comes out to be uk minus 1, k ranging from 1 to n. So what does that come out to be? Okay, so finally I will be getting u n minus u naught. When k is 1, I will be getting u1 minus u naught. What is u naught? Okay, if this were to be u naught, I mean, what would be u naught here? 0 into 0 plus 1 factorial. So it comes out to be simply un only. U naught is 0 for us by choice, because I have taken uk to be k into k plus 1 factor. So we have u naught to be 0. So that's fine. Finally, what we get is un. What is un? N into n plus 1 factorial. So that makes it n plus 1 factorial. So the final answer here is, answer is 2 there. The sum to n terms of the series 1 by 1 factorial into 1 by 2 plus 1 into 3 by 2 factorial into 1 by 2 square, 1 into 3 into 5 by 3 factorial into 1 by 2 cube, so on up to n terms, is product of n plus 1 consecutive odd numbers, that is 1 into 3 into 5, so on up to 2n minus 1 into 2n plus 1 by 2 power n into n factorial minus 1, 1 minus the product of n consecutive odd numbers divided by n factorial square. Then third option being 1 minus product of n minus 1 consecutive odd numbers by 2 power n minus 1 into n minus 1 factorial, product of n minus 1 consecutive odd numbers divided by 2 power n minus 1 into n minus 1 factorial. Now again, as we know, whenever we are looking at the sum up to n terms of a series, we first write the general term and see if there is any relationship between the nth term and n plus 1th term. That is another technique that we adopt here. What is the nth term here? Nth term of the series is 1, 3, 5 product up to 2n minus 1. So n odd numbers, product of n odd numbers. Here we have that divided by n factorial into 2 raised to the number of factors that you have in the numerator. How many factors are there in this numerator? N factors are there. Okay, n consecutive odd numbers are the factors here, and you have 2 power n factorial. Now what is Tn plus 1? Observe what is Tn plus 1. Tn plus 1 would be 1 into 3 into 5 so on up to 2n minus 1 into 2n plus 1. That is, you will have n plus 1 consecutive odd numbers. So you will have to write n plus 1 factorial here. So that n factorial into n plus 1 will write 2 power of n plus 1, that I will write it as 2 power n, okay, into 2. So now what are the extra terms when you compare with Tn and Tn plus 1, right? This part is present in Tn as well. Product of n consecutive odd numbers divided by n factorial into 2 power n, that is nothing but your Tn. So we can write therefore Tn plus 1 as, come on, tell me, Tn into 2n plus 1 by 2 into n plus 1 there. Okay. So that makes it 2 into n plus 1 into Tn plus 1 minus n into Tn. You cross multiply, take 2 common, and then we have, leave Tn this side. So Tn. This is what is the relationship we have between Tn and Tn plus 1. Now don't you see there is some kind of a telescoping form that we are able to express it in. This, if you call it as un plus 1, this is like un. So un plus 1 minus un. That is, it is written as a difference of two consecutive terms. So nth term here is being expressed as difference of two consecutive terms of some series. So we wanted sum up to n terms here. So what we do is, we first write out the kth term. What is the kth term? Sigma, that is 2 into k plus 1 into tk plus 1 minus k into tk. And we want summation of tk, k ranging from 1 to n. So apply summation now. Applying summation, sigma k ranging from 1 to n will give me sigma k ranging from 1 to n here. So what is that gives me? This is the telescoping method. So you will get, when k is 1, you will get 2 into t2 minus t1. So things will cancel, and what is it you get? Finally, you will get the first part of the last term and second part of the first term will remain. So what is that? We will have n plus 1 into tn plus 1 minus, what is the second part of the last first term here? When k is 1, you get 1 into t1, so that is going to remain 1 into t1 there. So this is what will remain. Okay, and this will be sigma tk, k ranging from 1 to n. That is what you require. That is sum up to n terms of the series. Now let's look at what was t1. What was t1? t1 would have been 1 by 1 factorial into 2 power 1 there. So 1 by 2. t1 is 1 by 2 there. Okay, so there is a 2 also multiplying here. So 2 into n plus 1 into tn plus 1 minus 2 into t1. So what is that 2 into t1? 2 into t1 is 1 there. Now this 2 into n plus 1 into tn plus 1 minus 1 there. Okay, now what is tn plus 1? Tn plus 1 is this 1 into 3 into 5 so on up to 2n minus 1 into 2n plus 1 by n plus 1 factorial into 2 power n plus 1 so on. So observe that we can rewrite this when you multiply by 2n plus 2 here, that comes out to be tn plus 1, 2n plus 2 into tn plus 1 minus 1 will turn out to be the first option there, 1 into 3 into 5 so on up to 2n plus 1, because this n plus 1 into 2 will cancel with that term there. So 2n plus 2 there. What you are left with is n into n factorial into 2 power n, that minus 1 there. So that makes it the option, right option being here answer 1 there. Answer is 1. If a1, a2, a3 so on up to A4001 are terms of an AP such that 1 by a1 a2 plus 1 by a1 a3 plus so on 1 by A4000 into A4001 is equal to 10 and A2 plus A4000 is equal to 50, then the absolute difference, that is A1 minus A4001, is equal to first option 20, second option 30, third option 40 and the fourth option being 10 there. Now A1, A2, A3 so on A4000, A4001, this 4001 terms of this series, they are in AP given. Let D be the common difference. Let us assume that D is the common difference. Common difference, let us assume it is D. Okay, so that is D is equal to A2 minus A1 and that's also equal to A3 minus A2 and so on, so forth, An minus 1. Now this 1 by A1 A2, let's write a general summation here, general term in the summation 1 by AK plus 1, K ranging from 1 to 4000. That's what you have in the summation. So what is that? What we'll do is we'll add and we'll multiply and divide by d. Every term will multiply and divide by d, so that d can be brought out, and this d here I'm going to write it as ak plus 1 minus ak divided by ak into ak plus 1, k ranging from 1 to 4000. And this summation is actually given to be equal to 10. This is 10 given. Let's simplify this now. What is it you observe? Split it into partial fractions. ak plus 1 minus ak by ak into ak plus 1. When you split it into two fractions, what do you get? 1 by ak minus 1 by ak plus 1, k ranging from 1 to 4000. That into d. Now this is in the telescoping form. That is, it has been brought into the difference of two consecutive terms. When you apply the summation, what is it that remains? 1 by a1 minus 1 by a4001. Okay, so all the middle terms get cancelled and you will be left with this d into this. And what is this equal to? A4001 minus a1 by a1 into a4001. Okay, that is 10 for you. There's a 1 by d here. It's a 1 by d here, 1 by d here. So now what is this a4001? That is the 4001th term. What's the difference between the 4001th term and the first term and the AP? 4000d. So 4000d divided by d, that makes it 4000. So 4000 divided by 10 will be your a1 into a4001. Okay, this is 400. So a1 into a4001, we are finding it to be 400. Now, we also know one fact in AP, a sequence which is in AP. The sum of the first and last term is equal to sum of the terms which are equidistant from the first and last. We are given in the problem a2 plus a4000 to be equal to 50. This has been given to be 50. So can I now say that a2 plus a4000 being same as a1 plus a4000, 1 is also 50. So this is what you have. Now the sum of these two terms, a1 and a4001, is 50, and the product is equal to 400. And it's clear that you can just see from inspection, one of the numbers should have been 40, the other number should have been 10 there. 40 plus 10, 50, 40 into 10, 400. So a1 and a4001 must have been, one of them should have been 40 and the other would have been 10 there. So the difference will be 40 minus 10 or 10 minus 40. Absolute difference is what is required. Therefore, the answer is 30 there. That makes it modulus of a1 minus a4001, we can say, will be 30. Therefore, the answer is 2. Let's move on to the next question. If an is equal to sigma k ranging from 0 to n log 10 to the base e power n divided by k factorial into n minus 1 k n minus k factorial for all n greater than or equal to 0, then sigma an's n ranging from 0 to infinity is equal to 10, 10 square, 10 cube, 10 power 4. These are the four options. Let's have a look at the an there. What is an? Sigma k ranging from 0 to n log 10 power n by 1 by k factorial into n minus k factorial. Observe that here in this n is fixed and what is varying in the summation? K is varying. So this log 10 power n can be brought out of the summation. Log 10 power n can be brought out of the summation. And now you have sigma k ranging from 0 to n 1 by k factorial into n minus k factorial. Now, you observe that in this part, the summation in this, the general term, if we had n factorial in the numerator, it would have been n factorial by k factorial into n minus k factorial, and that would have been nck. So what I will do is, we will multiply and divide by n factorial. N factorial in the summation, that's commonly multiplying, so I will bring it out. So now what is this? N factorial by k factorial into n minus k factorial, that is nothing but nck. Sigma nck k ranging from 0 to n, sum of the binomial coefficients in the expansion of 1 plus x power n, and that's clearly 2 power n. So this is this into log 10 to the power n by n factorial. That is what is your this thing. So that comes out to be, this is 2 power n. So 2 into log 10 raised to the power n by n factorial. This being 2 power n. This 2 power n and a log 10 power n, I am clubbing them up into one base. So we'll have 2 into log 10. That makes it actually, what does it make it? Log 100 raised to the power n, because 2 log 10 we can write it in the form of log 100 raised to the power n by n factorial. Now what do you want? We want sigma n ranging from 0 to infinity. So that makes it log 100 raised to the power n by n factorial, n ranging from 0 to infinity. We know that summation sigma x power n by n factorial, n ranging from 0 to infinity, is e power x. This is the key formula that we are using, formula that is used in this problem. So log 100, in place of x we have log 100, so that makes it e power log 100. What is e power log 100? That's clearly 100, which is nothing but 10 square there. So the answer is 2. Answer is 2 there. The sequence xk is defined recursively by xk plus 1 is equal to xk square plus xk with x1 equal to half, then bracket function of 1 by x1 plus 1 plus 1 by x2 plus 1, so on so forth up to 1 by x100 plus 1, where bracket denotes the greatest integer function is equal to first option 0, second option 2, third option 4, and fourth option being 1 there. Okay. What are we given? We are given that xk plus 1 is equal to xk square plus xk. And this is valid for all k there, k greater than or equal to 0. Now, what about x1? We are given that x1 is equal to half. So can we generate x2 from here? x2 will be half square plus half. That makes it 1 by 4 plus 1 by 2, that makes it 3 by 4 there. x3 is 3 by 4 square plus 3 by 4. That is 9 by 16 plus 3 by 4. Okay. So we can write this as 12 by 16. So 21 by 16 there. We find some pattern in this. You observe that x1 is less than 1, x2 is less than 1, but what about x3? That's becoming greater than 1. What do you think will happen? Will come out to be x4. x4 will be 21 by 16 square plus 21 by 16. This number is greater than 1. So square of it will also be greater than 1. You are adding a 1 to it. You are adding a number greater than 1. It will be greater than 1. In fact, we can say it will be greater than 2. So, but anyway, we'll say it's greater than 1. Now, so from third term onwards, we find that all the terms of this sequence that so generated is, so xk we can say is xk is greater than 1 for all k greater than or equal to 3. This is one observation which will help us in doing the problem in a later stage. So let's see how we go about doing this problem. Okay. Now coming to this, so this observation that we have made, we will keep it aside and let's remove all this now. We have xk to be greater than 1 for, we have observed that xk is greater than 1 for all k greater than or equal to 3. This is what we have observed. Okay. Now let's continue with this now. Let us go for 1 upon xk plus 1. What is that going to be? 1 upon xk square plus xk. We can take out xk common and we can write this as xk into xk plus 1. 1. Now can we split this into partial fractions? A difference of two terms we can write it as 1 by xk minus 1 by xk plus 1. Please observe, it's not in the suffix, we are adding a 1 to the term there, xk plus 1. And here we have x of k plus 1, that is a k plus 1 term here. Now what I do is I transpose this term to the left. This term will go to the left and these two are interchanged. So then I'll get 1 by xk plus 1 will be 1 by xk minus 1 by xk plus 1, x suffix k plus 1. Now what is the advantage of doing this? We could write this term at the left hand side as a difference of two consecutive terms of some sequence. So then what is it you want? We want the sum up to sum of the left hand sides k ranging from 1 to 100. So let's apply k range, summation k ranging from 1 to 100. First let's find out that. So that makes it k ranging from 1 to 100. So what do you get? Again it is 1 by x1 minus 1 by x2, 1 by x2 minus 1 by x3, all of them will cancel in between and we'll be getting 1 by x101. What is 1 by x1 by the way? X1 was half, so 1 by x1 is 2. Now what about this term we have written? It is x101. Is 101 greater than 3? Of course it is greater than 3. So what do you have? 1 by x01, that has to be less than 1 there. So this will be 2 minus a quantity less than 1 but greater than 0. So 2 minus, okay, 1 by x01, we'll say 101. We know that 1 by x101 is less than 1. Okay, and it is greater than 0. So when you are subtracting from it, 2 minus 1 by x01, x101 will have to be between, what's the least value? Will be 1 and it will be greater than, less than 2. So this will be lying between 1 and 2. So what will be the bracket value of a number which lies between 1 and 2? So this entire summation is lying between 1 and 2, therefore the bracket value will have to be 1. So the actual value is 1 there. So the answer is 1, and that 1 comes out to be in the fourth option there. So answer is the fourth option.